Hello students, in this video I'm just going to talk about a summary of all the things that we've talked about involving quadratic equations and the graph of the quadratic equation, which is called a parabola. Just because, in the past couple of lessons we've talked about a lot of different equations and a lot of different formulas, so I just want to maybe just try to capture the essence, okay, in this one video. Alright, so here we go. So what I'm going to do is just I'm going to because in the derivations that I did, I created I derived the equation for a parabola that's horizontally oriented. I'm just going to start to talk about the vertically oriented parabolas. So let's take a look at this. So a vertically oriented parabola, okay, will take on this form here, and every parabola will have a focus. Every parabola will have a focus. Every parabola will have a vertex, and every parabola will have a directrix. Not every parabola, however, will have roots. Not every parabola will have roots. Real roots, that is, okay? Every parabola will have some form of a root. It could be imaginary or it could be real. But, so depending upon how the vertically oriented parabola is situated. So there are a bunch of equations that are associated with this, with the quadratic equation, with the parabola. So let's take a look at it. Okay, so we can describe all the points that are on the parabola that are on this curve by the equation written in standard form, and that is ax squared plus bx plus c. And we've gone through just exploring the different effects that that a has, that leading coefficient has, on the overall parabola, and the contributions that the other coefficients, coefficient b, and as well as the last term c has in the effects of the roots. Okay. With the standard form, okay, we were able to develop a couple of formulas associated with this, and that is describing the axis of symmetry, which is x is equal to negative b over 2a. Depending upon the situation with the quadratic equation, if it is factorable, then we can express it in factored form, where R1 and R2 are the roots of the equation. Again, depending upon the situation, not every quadratic equation will have real roots. Sometimes it will have only one real root, or sometimes it will have two real roots. Sometimes it will have no real roots. And depending upon the situation, if the roots are real or not real, if the equation is factorable or not factorable, we can always solve for the roots by using the quadratic formula. And again, that was derived by completing the square. Every parabola, every quadratic equation will have a vertex, and the vertex is located at h comma k, which I've also denoted in the diagram here, right? So h comma k is the vertex. So as it turns out, h comma k being the vertex, that is also the x-coordinate of the, well, the x-coordinate of the vertex happens to also be the axis of symmetry. So h, therefore, is equal to negative b over 2a. And in the past couple lessons, okay, we looked at some applications of modeling a lens. Okay, we looked at the inner operations of the human eye, and that lenses, okay, all have a focal point, and we were able to develop some working models of those. Okay, one of which was the directrix, and if we were to model a lens, that would be the first. That would be the path that the light would enter the lens. So in this case, for a vertically oriented parabola, the directrix is going to be a horizontal line, right? Which is why I have written here y is equal to k minus p. So p here has a significance, right? What is the meaning of p? P is the distance between the vertex and the directrix. It is kind of like the thinnest point on the lens. If you have grandparents, or speaking for myself, I used to have really thick glasses. Like if you look at people with really thick glasses, you're going to see that the lens, okay, is going to be curved, okay, on one side and flat on the other. Okay, this is for primarily like nearsighted people. Okay, the focal point is going to be brought closer. Okay, so the certainly I'll try to find my my glasses to show you guys actually the shape of the lenses of an actual pair of glasses will look very similar in shape. Okay, so you're going to have a flat side and a curved side. The flat side there is the directrix, okay, and characterized by a horizontal line is y equals to k minus p. And we also developed the location of where the focus is. The focus is going to be p units above the vertex. So for that reason, we're going to add p to the y coordinate of the vertex, which is why now we have h comma k plus p. And then we can re-express the equation of the parabola, not in standard form, but we can re-express it in vertex form. And then in the derivation that we did in the previous video, it was found that the leading coefficient a had told a lot more, gave us a lot more information about the parabola. It told us where the directrix and focus is going to be situated, because the leading coefficient is equal to 1/4, is equal to 1 over 4p, where p again is the distance between the vertex and the focus, or between the vertex and the directrix. So with that understanding, the equation of the parabola in vertex form, if we wanted to incorporate this idea of the directrix and the focus, the equation would transform to look like this. Similarly, if we talk about the parabola that's horizontally situated, that's horizontally oriented, it would look something like this. And the equations look really similar. The only difference is everything will be expressed in terms of y, whereas before, when we were graphing things vertically, everything was in terms of x. So we have x is equal to ay squared plus by plus c. The axis of symmetry this time is going to be a horizontal line, which is negative b over 2a. When we rewrite the equation in factored form, the roots this time is not going to be on the x-axis, but rather it's going to be on the y-axis. The quadratic formula is the same equation, okay? It's just everything is expressed in terms of y. The vertex of the horizontally oriented parabola is again still h comma k. However, this time the axis symmetry is going to be a horizontal line, and it's going to be y is equal to negative b, or k is equal to negative b over 2a, k being the y coordinate of the vertex. The directrix in this case, because the parabola is horizontally oriented, the directrix will be a vertical line, and because of that, we're going to have x is equal to h minus p. The focus is going to be horizontally positioned, so it's going to be to the right of the vertex. And when rewriting the equation of the quadratic equation in vertex form, it's going to look exactly like the quadratic equation in vertex form for a vertically situated parabola. The difference is it's going to be in terms of y. And again, if we wanted to rewrite the equation incorporating the directrix and focus, the equation for the parabola can be re-expressed having P incorporated, and that would tell us where the directrix and focus would be situated. So this formula sheet, okay, it's important. There's a lot of information here, as you can see. Do I expect you to like memorize everything in here? I kind of do. However, with that said, I don't want you to try to memorize this by holding a bunch of index cards and memorizing it that way. I mean, I always take math and everything we do in life to be something that we internalize, right? So take a violinist or a pianist or a baseball player, a basketball player. They do what they do, okay, not because of memorization, but because they internalize a lot of the skills and a lot of the knowledge with the discipline or with the particular act that they are performing. So it is quite an illusion, okay, when a person steps up on stage or when they step out on the court and they're able to do these magnificent things, okay, that's because they have all the information internalized. So I want you to internalize this information as well, not by rote memorization, but by practice. That is the only way that you can internalize this. If you sit there and try to memorize this without, rolling up your sleeve to practice applying this, then it's going to be a huge mountain to overcome. So, the only way to internalize this is to have enough practice.